Is Python your type of programming language? Take it away.
Thank you. So this title contains a little bit of a lie that I sussed out. And when I said, how to use static typing in Python with type hints, MyPy and Pydantic, it's a little misleading because Python is and remains a dynamic language. But what these tools do is they kind of overlay some static checking capabilities into Python so that you can treat it as if it's static, even though it remains dynamic under the surface. And I'll show some examples of that a little bit later on. So first question, what is a data type? And it was kind of hard to answer because the first bullet point there says a category for data in your Python program, which is sort of like saying data type is a type of data. It's very circular, but fundamentally you can think of it as what it does. Knowing the data type answers the question, what is it? What are you going to put in that data structure? And what can you do with it? What can't you do with it? So just going really back to basics there, identifying what a data type is. So it determines what the data is and how do you use it. So the check marks show you valid things to do and the X's show you invalid things to do. You can multiply two numeric types, a float and an int, or two floats, things like that. You can add two strings together, string concatenation. You can add a time interval, like in Python, a time delta to a date or a timestamp or date timestamp. More complex one, you can transform a coordinate system of a point cloud. But there are things that data types constrain. For example, you can't multiply a string by a float. It doesn't make sense. You can't divide a string by a dictionary. That doesn't make sense. So data types are really, really important because they tell you what you can and can't do, what operators you can use, what functions you can use. And fundamentally, that's governed by what the data type is. Many of you will be familiar with the set of data types that Python has: scalars, sequence types, the dict, the very versatile dict as the mapping type, built-in classes, etc. Types of typing, just take a quick look at this. Static typing, this is what we see in compiled languages. The data types are locked in at compile time, and that's it. That's what they are. In Python, we see dynamic typing. So if you assign a value to a variable name, that can change in the sense of a equals 1, then you have an integer value stored in a. But a equals foo, the string, you've just stored a string in a. That changed the type of value stored in a, and this is totally valid Python. But Python is also strongly typed. Strong and weak is a continuum, of course. There's varying levels of type strength, and this is an active area of research, but fundamentally strong typing means you can't convert one to another without, for example, casting it, whereas weak typing, this is typically more seen in scripting languages. Weak typing, you can say, for example, a equals quote 1, it's a string, but you can treat it as an integer because it's a string, a string representation of an integer. So fundamentally, Python is strongly typed and dynamically typed. As an interpreted language, it doesn't have a compile time. So static typing, this goes back a number of years. There was a PEP, a Python enhancement proposal, almost 20 years ago now for function annotations. And that kind of kicked things off, but there were earlier experiments that I won't go into. Really, this all started, I would say, around 2012. So 12 years ago, Yuka Letosalo, I think I pronounced his name right, started the MyPy project, and that was based on his academic work. That's the MyPy static type checker that kind of operates like a compiler for Python code. It checks the types, and we're going to take a look at that. In 2014, PEP 484 came out. That was strongly influenced by MyPy, and that introduced type hints, which made it into the language in version 3.5 about a year later, and that we see in the typing module. In 2017, the kind of third leg of the tripod that I'm talking about here, Samuel Colvin started the Pydantic project, which is something that we're going to take a look at in a little bit. So, look at. I find this stuff is a lot easier to dive into rather than talk about. So, hence, show, don't tell. Great. So I've got a few small scripts here that kind of illustrate the way these things work. So here's an example of type annotation. So we import the typing module, and this is valid Python when you use colon and then the data type, and then you assign the value there. So good int is an integer. That's what our type hint tells us, and we assign it an integer. Good str is a string. We assign it a string. And interestingly, the type hinting, aka type annotations, these are the same thing, it's still valid Python. So this line here, even though we're lying when we say it's a string, we actually assign it an int, this is still valid Python. The string is just a hint, it's just a suggestion, but tools will use this. Tools such as MyPy will use this in order to flag errors like that. And this is a really obvious error. We say it's a string, we give it the string type hint, and then we assign it an int. So this is just kind of a cooked up example here. This gets a little more complex. You can use the typing module to provide tuple type hints. So this is a tuple of 2 ints. You can mix your types. So this is a string and an int. You can have an arbitrary length tuple. So for example, maybe we don't know how many items are going to be in our tuple, but we know that they're going to be all strings, for example. We can offer a type hint. Here's a list of strings. We can add a string to it. And again, we can break the rules here and add an integer to this list that we just said was a list of strings, and then we add another string. This is actually still valid Python, so we can lie and say it's a string and then add an integer to that list. This is still totally valid Python, but MyPy will flag that and say, hey, are you sure you want to do this? You're breaking the rules that you set out for yourself. So functions. The syntax is the same for function arguments. Basically, argument name, colon, data type, argument name, colon, data type. And then the return type uses this little arrow operator, like hyphen greater than, and that's your return type. So this is a super simple function, takes 2 ints and returns an int, and just uses the plus operator there. So very simple. And then when we run this, this is going to do a variety of things. We're going to use value A of 10, B of 20, sum of 10 and 20 is add A comma B, and MyPy will approve this because the types line up. They're all integers. Now, again, we're going to break the rules and say these are strings, not integers, and we're going to pass that in to the add function. Strings, of course, we can concatenate using a plus operator, and that will just give you the concatenated string. So if we run this one, which is one type annotations.py, we see my list is string foo, comma, integer 1, comma, string bar. Sum of 10 and 20 is 30, as expected. Sum of foo and bar is foo bar. So this is all, this ran without error. This is valid Python. But we told some lies in here. We said we passed in a string that should have been an int. We added an integer to a list that we said was a list of strings. So MyPy is going to have something to say about this. And we can see what it does here. So line 10, incompatible types in assignment. Expression has type int, variable has type string, so it doesn't like that. Argument 1 to append of list has incompatible type int, expected string, so that's argument type in the append function. And then in our simple add function here on line 58, we passed it 2 strings and we expected integers. So MyPy is really profiling this code statically and saying, okay, you said these types were one thing, but then you passed in different ones, and are you sure you want to do that? But again, it's valid Python. You can run it, the program runs, it's no problem. We'll take a look at a simple class here. So again, really basic example of a rectangle. A rectangle has a length and a width. The length is a float. The width is a float. And this constructor here takes 2 arguments, length and width, and assigns them to these class attributes. We have 2 methods, one of which computes the area, which is length times width. The other one computes the perimeter, which is twice the length plus the width. And so we run this here, and this is the correct usage. We pass it numbers, in this case integers, but integers can be treated as floats, so we're good. And we compute the area, we compute the perimeter. So far, so good. In this case, we're going to break the rules again, and in fact, we're going to break them so much that we get a type error exception. For the perimeter, we can actually sneak in some strings because you can multiply strings by integers because that just gives you repeat copies. But if you try to multiply a string by a string for the area of foo times bar, that's not going to work. So that's going to give you a type error, which we can capture here. So you run this one, which is the second script standard class.py. So R1 area is 50, R1 perimeter, excuse me, is 30. Let's see here. Yeah, so 5 times 10 gives us 50. 5 plus 10 is 15 times 2 is 30. So the arithmetic is good. R1 perimeter is foo bar, which doesn't really make any sense. So that's already a little weird. And then when you try to square a string, or excuse me, multiply one string by another string, you get a type error because you are doing something that Python does not understand and rejects. So if we run MyPy here, this will say, hey, what are you doing? You're trying to pass in a string to something that you said was a float. You're not being consistent with what you defined, and so you'd better take a look at that. So again, static type checking catches something that would be an exception if you just ran it. So in this case, we're using type hints or annotations. We're using MyPy, and in my talk title, you may have seen Pydantic. So this is another, another library, a third-party library, which will actually do these things at runtime, which is kind of cool. So we're going to import these from Pydantic, field, base model, and validation error. So you can think of Pydantic as a means of defining a schema for a data structure. So again, we're looking at a rectangle. Rectangle has a length and a width. And this is some interesting syntax. We're essentially just giving it class attributes here, which we've provided as float. And Pydantic does some interesting meta-class trickery to define them as field values. So what these are, they default to a field value. So under the hood, it's going to be something like field, and with a standard set of arguments. The methods are going to be the same. They don't change. But that's what I put down here. Creating an instance of a Pydantic model uses keyword arguments based on the schema defined in the class, which is derived from base model. So base model is the model from which all Pydantic models derive. And so our rectangle is derived from base model. And so you create this rectangle. Now you're not just passing in location arguments, but instead keyword arguments. So length equals 5, width equals 10, and otherwise everything is essentially going to operate the same way. So it's a slight difference, but basically looks the same. Now here we're going to lie to Pydantic, and Pydantic is operating at runtime, so it's doing something different from MyPy, and it's going to reject this. This is now not valid Python from Pydantic's point of view, because now we're in Pydantic's library world, not just in regular vanilla Python. So that's something important to take a look at here. So we define rectangle R2 as we did in the previous case. Length is foo, width is bar. We try to compute the perimeter and the area. And with the benefit of foresight, having run this code before, it's going to throw a validation error, which is a specific Pydantic exception. And we'll take a look at that when we run this. Moving on, this is pretty cool. If we try and create a rectangle with string values, so we're passing in strings, but these are strings that happen to contain integers. Pydantic is very smart about things if you want it to be. You can also do strict, basically strict mode is what they call it, where it will say, no, I'm not even going to look at this. This is a string. You said it was an int. I'm not going to try and convert it. But its default is to at least try and say, well, if I can convert this, I'm going to, and treat it as an integer value. So we run this here. So this is the Pydantic class, and we get a long and rich error message. So this is the exception. 2 validation errors for rectangle. Length. Input should be a valid number. Unable to parse string as a number. Type float parsing, input value foo, input type string. Gives you a URL that you can go to look things up. And then basically the same thing for the width, because we passed in a string for the width and a string for the length. But this is very interesting here. We did that here as well, but it was able to convert it because those were numbers. These were strings that contained only numbers. If, for example, I do 4e, or actually maybe 4, that might do some kind of scientific notation. So let's try 4z or something. That should break it now, because now it's no longer, yeah. input should be a valid number, unable to parse string as a number. For Z, it gives up and says, I don't know what you're trying to do here. I can't convert that into a number. So Pydantic is a very cool library. It's huge and very powerful. And actually, we haven't looked at this one in MyPy, but what does MyPy say about this? OK, so it finds all of the things that we would expect. When we pass string into the rectangle constructor, it says, hey, what are you doing? You need to float here. And it does that in the case in line 56 here, where Pydantic says, oh, I think I know what you're doing here. I think you want this string to be converted to an int, and so I'm going to give that to you. But again, that's tunable with this strict argument. And that would be something here where you define this as a field, field, and then strict equals true. And if we do this, then that third case will now fail because exception reported for R3, one validation for error for rectangle. We're saying no, this particular argument, but only the length is now strict. So it's not going to do that conversion. So Pydantic offers you a ton of flexibility and power here. So let's see here. So let's see, how are we doing on time? So type hints, these have been around for almost a decade now. I was going to say they don't have runtime effects, but again, Pydantic shows that's not true. They can have runtime effects. So what I said instead was they don't have accidental runtime effects, meaning anything that does runtime activity with type hints does it deliberately. If you just put them in and run vanilla Python, it's not going to change things. So type hints are like the foundation, and then all this other stuff is built on top of it. And I'm looking here at MyPy and Pydantic. There's a more recent MyPy-like tool out of Microsoft called Pywrite that you may have heard of, which basically does static type checking and integrates with your IDEs. So there's all kinds of tools that make use now of type hints. The syntax, we took a look at that. The typing module provides definitions for all these different types, sequences, generics, which I haven't even mentioned, union types. It gets complicated because data typing is complicated. So MyPy, static type checker, it kind of acts like a compiler. It'll go over your code and say, hey, what are you doing here? These types don't line up. They don't interfere with normal program operation. And one nice thing is that you can add this incrementally. If you don't provide a type, it will basically assume that it's t.any or typing.any, which means it can be any type, which is kind of the default. Pydantic, powerful third-party library, validates data at runtime. You've got this strict mode. This, again, is another huge, deep rabbit hole that you can do a lot of different things in. So in this quick talk, we've only scratched the surface here. Something to really emphasize, these tools work together. Type hints alone, they're basically comments. MyPy without type hints doesn't really do anything. Pydantic, same thing, no type hints. It really isn't going to do anything for you. So you're going to have to use them in combination, which is why the talk is about these three different tools rather than just one of them. Are they mainstream? Is this best practice? Just a quick review. Like I said, type hints have been around for about a decade in Python. MyPy is over a decade old, thousands of commits, thousands of forks, stars, many contributors. Pydantic, younger, but still, again, a very, very active open source project. So they are mainstream. They're used by big organizations. You can and should use them. Strong strong yes to they're ready for prime time. So probably the easiest way to do this is to do it incrementally. You don't have to refactor a million-line code base and say, OK, I've got to add type hints everywhere and run MyPy on it and so forth. You can add them incrementally to new code, refactored code, add MyPy to your workflows. And Pydantic is really for the boundaries of your system where your data comes in and out. So those are kind of places where you can add these tools gradually. So typing, type hints are actually like comments. They're basically telling you in 6 months or telling somebody else who is reading your code what you think that data is going to look like, the data type. MyPy will scan those and tell you when you're lying to yourself about what your data is. Pydantic validates incoming and outgoing data. They really are mainstream and reliable best practice, and they will help make your programs easier to debug, detect errors, detect bad data coming in, and these tools all work together really nicely. So how to get started? All three of these, I mean, typing is part of the main, it is part of Python. The documentation is excellent. MyPy and Pydantic both have excellent documentation, so read the docs, play, learn what happened when you played, rinse, repeat. That's my recommendation there. So just have fun with it. Play with it and see how it helps you out. Thank you so much for your attention.